So we've already talked and discussed a little bit about what event notifications are in the context of fault management overall. So let's look into a little bit what event notifications look like within SNMP and how you handle them with netsnmp and Python. This is probably the nerdiest of all nerd quotes you'll see in these series of lessons. This is, yes, a Star Wars quote. So, SNMP traps are an unconfirmed message used to convey an event by an agent to a manager. It contains the following information: who emitted the trap, what occurred with the trap, when the trap occurred, when the event occurred rather, and any additional information stored in var bindings. We've talked about var bindings a little bit thus far. You, as the developer of a network management system, get to determine what you do based on this received information. So whether you just simply store it as in a log file, or you store it in a database, or you use it as part of a more sophisticated event correlation system. We kind of discussed that a little bit last time when we talked about fault management. So, Python itself, rather than SNMP Python library, doesn't offer a direct way to catch traps. There are other libraries out there that do within Python, but for the time being, let's focus on the netsnmp library since that's what we've been using in this class. Instead, we must use a wrapper or another application within netsnmp called SNMP trapd to catch these traps for us, essentially listen on the network for the router that's sending, or the agent that's sending the traps, and then do something based on those received traps. So you can configure SNMP trapd simply by editing the file etc snmp snmp-trapd.conf, putting in this first line, which says essentially what you're allowing to happen for the community string public. So we're allowing within SNMP trapd the ability to log and execute some kind of command. Then, this should be lowercase t, this PowerPoint automatically uppercase that for me, being nice I guess. You specify trap handle, then you can put in the trap OID if you want, and the command to execute whenever SNMP trapd sees an OID, a trap sent with an OID that you specified there, or you can just set a default command that will handle every single trap that comes in. So, this last line will do just that. You say trap handle, default, and then the path to the command that you want to execute. Let's pull up a router here. Before we even talk about dealing with Python or handling the traps themselves, we need something to generate those traps. We need to configure our agent on the router to generate those traps. So, let's get into the router, go into the config mode, and say SNMP server host, and we're going to put in the IP address of the management system, the community string that both the agent and the manager have agreed upon to use, and then the types of traps that we want to send. So if we just put question mark there, we can see there's quite a lot of different traps that we can configure the agent to send. If we don't press anything, if we don't specify any specific traps, it'll send everything possible. Or rather, it'll allow everything possible to go to that specific SNMP host. You can configure multiple management systems to send traps to by using that same command. So if you want to do another, for example, if you wanted to do another network management system, you could say, put the IP address of that in there. What we need to do now is configure which traps we're going to enable within the agent itself. So again, here we could say enable traps related to configuration, any kind of configuration changes. But if we just want to send all possible traps, just type snmp-server enable traps. And it's going to complain, depending on which router you're using or if you're using a switch. Some traps can't be enabled with other traps, so you may get some kind of warning messages. But generally, this will enable traps for everything. So now that our router is configured, we should be able to go and configure SNMP trapd. So let's do that now. Oops. So, as you can see, well, actually, I'll leave that in there. As you can see, I've already put the 2 lines in here that we need. So, the auth community, we're saying log execute, and oops, I left net in there. That just means that allows you the ability with an SNMP trapd to relay this message to the network to another host somewhere else. Execute again means you can execute a command, and log means you could log it using the built-in Unix logging facility, syslog, which we really haven't talked much yet about. And we're also saying that the community string is public. So what I've done is create a default trap handle, and I've told it to run Python, and then execute. I've given it a path of some code that will handle the traps or catch the traps. Now, let's start writing this code here. So home Hollywood DS trap lessons .py. So we're going to set up main. We're going to call main safely. And we're going to create kind of a standard just event loop. The reason why I'm doing this, come on. The reason why I'm doing this is that the SNMP trapd will send information about the traps to your program via input. So just like the user is, when you ask the user to type input, SNMP trapd is going to work the same way. So you need to call raw input. But we want to continue doing it till we reach the end of line character. We probably want to, just for now, we'll write all the traps out to a file. We'll say, and just append. And we probably also want to put this in an exception. We want to catch an exception here. We're doing this again because we want, let's close that up. Because when we call raw input, or rather when SNMP trapd executes our Python program, again, it's going to send text to it just as if it was a user inputting text into our program. So we're going to call raw input. When it's done, it sends what's called an end of file character. It's a special character within Unix that just indicates that there's no more data to be transmitted. So we probably also want to do something with this here. We're going to output.write. I'm going to write this out to our file. I'm going to write the input out to a file rather, and then we'll also put a new line character at the end of it just so it formats pretty. So we can test this out just by ourselves here. We don't have to worry about running SNMP trapd. So as you can see, it's expecting user input now. So we can write this is a test, and I'm going to press enter and then hit Control D on the keyboard. That sends the end of file character to the program. So if we look under temp, we should see a file, temp traps. So we can see it wrote out everything that was typed into the input of the program. So I'm going to clear that file out, and then I'm going to start running. And you have to run this as sudo snmp trapd. I'm going to pass it -g and tell it where to find the config file. Now what this is going to do is this is going to run the trapd daemon in the background, and it will listen for traps coming in on port 162 UDP. When it receives them, it's going to, based on the configuration that we defined in etc snmp trapd.conf, execute commands. Right now it's going to execute that one Python program for any traps that it receives. You could get more specific and tell it to execute specific programs for specific traps if you wanted to. So let's just go ahead and generate some trap messages. Let's see, if I bring up and down an interface, so if we say shut, brought it down, no shut, and it may take a minute for the traps to propagate. Okay, so I've now received the traps from the agent. I cut some of the dead time out of the recording there, so if the transition was a little abrupt, that's why. If you look at the file under /temp now, and it's going to be, since we started SNMP trap D as root using sudo, it's only going to be viewable by root as well. So that's why I put the sudo on this. So now we can see all the good information about the traps. You can use this information in your program to do certain things. You can use regular expression to find where the trap originated from, which IP address, for example, or for example, what type of trap it is, the OID of the trap itself, etc. And then some other information. These are the var bindings related to the trap that I described earlier. It's just telling us that fast Ethernet 0 went down, etc. And also the community string of it. So that is the demonstration on how to deal with and handle traps. See you next time.